So I'll start with a freshly created Health Cloud org, Salesforce Health Cloud, and I'll install the membrane package. This is the package.xml file. By the time this installs, let us take a look at trying to understand what's the differentiator that the membrane framework has when compared to the other integration framework. The fundamental aspect of any integration framework that you take would be to have an option where we can configure the mapping between JSON keys and the Salesforce as objects and the fields. So we either use metadata custom setting or the custom objects, and then we'll create n records for n keys in the JSON for saving that mapping. In case of the membrane, how we achieve this mapping is we don't use the Salesforce data model, but instead we use the JSON structure itself to have that configuration. What's the benefit? Instead of having n records for n keys of your JSON, we just have one record where the entire mapping and many other configuration, as we will see later on in this video, can be saved in just one record. Okay, so to realize that, we have to understand how the JSON structure is created, or what's the relationship. We need to observe a relationship between the JSON and the Salesforce as object. A few observations. So here you see I wrote a query to retrieve the sample account record, and I have serialized it, and this is the JSON structure for the S object. So we have some field from the base object, that is account. We have some fields from the one of the parent objects. So operating hours is a lookup on account, and also this is a subquery which retrieves the child record, that is contacts which are related to this particular account. So here if you take a look at the JSON, how it's structured corresponding to the S object that's retrieved is the base fields, or the fields on the base object, that is account, are keys at the base level. So if this is the JSON structure which belongs to the account object, ID, since we are retrieving operating hours, by default it will bring the ID of that uh, parent object as well. So that one, few other attributes, they are at the base level. Fields that we query from the parent object via the lookup field, they form a sub JSON. So here there is a sub JSON, starts and ends with curly braces, just like your parent JSON structure. The key is the parent lookup field, and whatever fields we queried for that object are again forming the JSON beneath that sub JSON. And the child records that we query are arrays. So as we see, here is the key called records, and the type of this, or the value of this, is an array. So whatever child records we query, they will be coming under this particular key here as an array. So it's not starting with the curly brace. It's starting with the square bracket, which indicates it's a array. It will have multiple records. Multiple records of what type? Of contact type. So since contact is an object in itself, that again has a sub-JSON structure to it. So this property of the JSON that establishes a correspondence with your S object is what's being leveraged in the membrane framework. So let us quickly start and create a mapping for the patient FHIR resource, and we'll see how easily we can create the configuration to generate and consume the JSON with that one single configuration record. for both outbound and inbound. So once the membrane solution is installed in the org, we first need to assign a permission set so that the membrane app and all the configuration records are visible for creating a membrane record. So the permission set that we need to assign is the membrane admin. Once the permission set is assigned to the user, we can go to this menu option here and can land onto the membrane app. This is how the landing screen looks like. The very first step is to create an external data source record. The data source here we are assuming is an EHR system called Cerner. We have other EHR systems like Dr. Chrono, the Epic, where usually the electronic health records are saved. And the Salesforce Health Cloud, acting as an patient relationship management, would usually integrate with this EHR to have the electronic health records back and forth. So we created a Cerner external data source. Now let's go to the membrane definitions and have a configuration record created for the patient resource. So I'll copy paste this sample JSON so that we can then generate the uh, membrane, that is the mapping configuration, and do the mapping. So here is the JSON viewer and editor plugin that's available as part of the membrane solution, where we can copy paste, edit, view any JSON structure. That's another thread solution. I'll remove this large value that's there for the div just to save some space. As such, it doesn't matter, we can keep it as is. So once we have this JSON saved here, the sample JSON, the first step is to create the membrane, and we can do that by simply clicking the button that we see at the top right corner, the first button. So when we do this, it creates a sample default membrane and it generates the mapping by itself. These are the default mappings based on the keys that we have and the sample values that are there in the sample JSON. So here, as you see, for every key that's there in the sample JSON, the membrane also has a similar key. And when we expand each of this key, there will be a sub JSON structure which we call as a cartridge, and that cartridge defines the actual mapping of the field with the S objects and fields in Salesforce. The keys that we see in the beginning of the membrane JSON in the right hand side, they define the mapping and the definition for your primary object. So this sample JSON belongs to the patient resource, right? So this particular set of keys before the membrane defines what is the definition and how it maps to the object. The name is derived from the field on membrane definition. There is a field called main object label. If we already have an object existing and we know the mapping, we can enter the API name of our object, and while generating the membrane, it will automatically take that value and will use as a mapping. If we don't have that label populated, it will by default use this name. Now, if we expand each of the keys, as I mentioned, we call this subJSON as a cartridge, and each cartridge defines the mapping for the individual keys in the JSON. So as we discussed, like how the JSON structure actually corresponds to your S object, the membrane automatically identifies whether the key is a lookup field or whether it corresponds to the child records. And also the sample values gives the framework the ability to identify the type of the values. If it's a boolean, it will define the type of the cartridge as boolean. If it's a lookup, it will define it as an object. If it's a child record, it will define as an array, and so. So this is how intelligently the membrane framework is designed, where it reads the sample JSON and generates almost all of the mappings based on the sample values. Now here, since text is a sub-JSON in our sample JSON, it means that it is a lookup field on the primary object. So there should be another object to which there should be a lookup field on our current primary object. So the membrane gives you the option where you can define that lookup object as well, and all the required fields that are needed for creating an object, like the name field, the type of the name field, whether it's text or auto number, the default record type that should be used when we create a record of that object, are all being made available on the membrane. So we can define those right within this single record along with the mapping. This prefix that you see here for every object and field is derived from the external data source. There is a field name unique prefix. The purpose of this is that if your current org is namespace, then later on when these custom objects and fields are prefixed with that namespace, the membrane can be quickly updated by doing a simple find and replace using this JSON editor. So for example, if the current org is namespaced as Cerner, then once we create the objects and fields, we can do a global find and replace by finding and replacing like this. So coming back to the mapping, now instead of the default mapping that the membrane framework has populated in the JSON, if we want to change it with the existing object, we can do this way as well. When you go to this SObject field or external ID field, lookup fields, etc., the framework will show all the objects and fields that are already present in the org. Similarly, the record type that's available on that object will be also shown, so that we don't need to go to that object definition and then look out for the record type, developer name, the API name, etc. So that really makes the process of configuring the membrane very fast and easier for the admin or the developer. The skip for DMA option is used if we don't want to create an object if that object is not present while generating the data model. So once this configuration is done, we have a button here named Generate Data Model, and what it will do is all the custom objects and fields that are used in the membrane but does not exist in the org will be automatically created by the framework. It will also update an integration user permission set, so that again you don't need to go through the hassle of assigning the access to these objects and fields for a particular user that is used for the integration. So let's select some of the existing fields for some of the keys so that we can demonstrate that facility as well. Once this entire configuration is saved, we verify everything, we can quickly go and get the data model, that is the SObject and fields created. The cartridge type, as I mentioned, is derived from the values that we have in the sample JSON, and there is a special value called object asses. We use this whenever we have a situation where the sample JSON is structured in such a way that we cannot have objects or fields created for them. For example, the identifier option that you see here, it has a array inside it, and within that there are again few other sub JSONs. Now we cannot really have a separate objects created for that. So what we can do is we can set the cartridge type as object asses, and then get the membrane regenerated. What happens in the background is it will map this against a text area field, and whenever the mapping runs as part of the integration, this entire sub JSON will be saved to that field and vice versa. We can then have sub processes that can generate this sub JSON and save in that text area field, so that the outbound integration can then take this sub JSON and map it to give you the actual JSON. So this way we can have covered situations like that, where we cannot have objects for every sub JSON that's there in the sample JSON. So I have set the cartridge type for the identifier key as object access. Now let's save it and then regenerate the memory. The generate membrane option can be used multiple times. So whatever changes you do to your membrane JSON, it will be preserved. Only the ones which did not exist previously will be added or updated. But your all your changes will be preserved even if you use that multiple times. So here, as we see, the identifier is now configured against the text area field. So whenever the membrane runs, this entire sub JSON that we see here from the JSON will be saved as is to that field, and vice versa will also happen. Okay, there are another type of keys where you um, don't have a field mapping available, and there is a static value that needs to be sent when you run the integration. For example, the resource type field, here the value is fixed, that is the patient static string. So for those scenarios, what we do is we map that as uh, by checking the not a field as true, and whatever fixed value, static value is to be provided, we set that to the default. Similarly, there is a boolean called read only. We check this if the field is to be considered, or the mapping is to be considered only during outbound, and it should not be used to override a field in your Salesforce when the JSON is received in the inbound direction. Another interesting and powerful feature of the membrane framework is the mutation capsule. Even after adding all the possibilities of considering the mapping for all type of fields, there will be scenarios where a direct one-to-one mapping is not possible. For example, a key might have the epoch seconds being sent from the external system, and you need to convert that to a date time field. To achieve that, we have this interface class that we can override, and whatever custom logic we have, we can write here to convert the key to field and field to key in two different methods. Once you have this class implemented, whatever name is used for your custom class, you can use that in the membrane against this interface class under the mutation capsule. What will happen is, whenever the framework runs, instead of using that field for mapping, it will execute, it will run this interface class, and whatever value is returned from the method will be populated against your JSON. So that way, if you have a complex mapping which cannot be achieved by simply mapping it to the field, you can have the mutation capsule feature used. The mutation capsule also have the additional feature or additional key called metadata, where you can pass in some fixed key value pairs which is required in your business logic. So if you have like 2 to 3 fields and you just have one mutation capsule class, you can pass different key value pairs to identify that the interface class is being called for which particular field. Now that our membrane is ready, let's generate the data model by clicking this button named as generate data model. It will give you two options. One is validation only, and one is to create the data model. So before having the objects and fields directly created, we can just have one round of validation by selecting the first option. It will generate the list of all the objects and fields that will be created, and it will populate on the record. So in the details section, once the tasting job is completed, you can see what all objects and fields will be created as part of the data model creation option, and also what permissions would be added to the integration user permission set that we discussed earlier. So if you find everything is as per your configuration and all looks okay, you can go ahead and click the generate data model, this time with the creation option. There are certain points that we need to take a note of. The naming convention should be as per what Salesforce restricts. So, for example, the birth date field with an underscore that we see needs to be changed, because underscore at the beginning or double underscore are not allowed. Similarly, there will be other such restrictions applied, like we cannot use reserved keys in the names. So if such scenarios are there, we need to catch it, we need to make the necessary changes, revalidate, and then get the data model generated. Otherwise it will fail. We might have to do this activity multiple times, where we might encounter some wrong naming convention being applied, so we'll have to correct it, revalidate it, and keep checking it. Once the validation is fine, we will go ahead and create the data model. The data model creation option again gives two options: to create objects and then create fields. First we need to create object, because only after that we can have fields created for the respective objects. Once the objects are created, we can then go ahead and have the fields creation, which will also update the permission set. The data model creation is done via async jobs, which are queuable classes. So there is a limit, as we know, in developer orgs and in trial orgs, we can just have 5 jobs chained via the queuable mechanism. Um, in the actual enterprises, or the limits are much higher, but even then, in the developer orgs also, you might encounter the depth limit reached when you have lot many fields and objects. You can just rerun the data model, so whatever are the pending fields or objects, that will be recreated. Once the job is completed, we can quickly verify from our details section that if at all the objects are created or not. We can then finally run the validation mode data model creation, um, and if the detail section is completely empty, that means none of the objects or fields are pending for creation. Similar to birth date field, there was a family field as well, which had an underscore, so that was supposed to be corrected. Now that all the objects creation is done, let us run a final validation. So here, as you can see, there are no new objects available for creation. So we can go ahead and do the field creation. So here you can see the maximum stack depth reached, because the number of queuable jobs increased more than 5. There were a lot of fields, right? So it's okay, we can just rerun and queue the remaining fields for creation. So a final validation, and we can confirm that the field creation is also completed. Uh, so no new fields are available. We can quickly check few of the objects as well if the fields are visible. So yes, we can see the fields also available on the objects. So now comes the health check part, where we will check if the membrane configuration, the mapping and everything is correct or not. So primarily it will involve two steps. First is to generate the records from the JSON, and then generate the JSON from the records. So since these new objects and fields were created without any profile permissions added, we will go ahead and assign the integration user permission set, which was created and updated as by the framework itself. So I'll just go ahead and assign that permission set. The health check is very simple. We just go to our membrane definition record. There is a tab called health check. We need to click this button called initiate health check, which will again via an async job generate a health check record, which will be shown once it's created. When you go to that record, you will again see some JSON structures under different accordion sections. The way the records are created using this membrane framework is by using the composite graph API. The benefit of this is that the different lookup and the child records that we have, the parenting of the primary object with those objects is automatically taken care by the composite graph API. All we need to do is make sure that the order of these records is following the order of the object structure. So the lookup record should be created first, then the primary, and then the child record. This references ID that we see here, which are then used as merge field to do that linking between the parent object, lookup objects, and the child records, are all taken by the frameworks. The order is also preserved based on the requirement by the framework itself. It uses the mapping and generates the body of the composite graph API, and we can just quickly go ahead and check the results. So we see there are some errors. So if there is any issue with the mapping or permission, etc., then those errors will show up. We can then quickly make those fixes, do a re-health check until we get success. We'll have to repeat this activity. So after about 20 to 25 health checks and some fixes at the object level, permissions, etc., I was able to generate a green health check record. So once you see that the composite graph result is showing as successful, you can then use this custom composite lookup, which is again a threads resource called polymorpher, where you can link the membrane definition record with the new record which was created as part of the health check. And once you select that and then run the second step of the health check, you will either see a fuzzy pass, strict pass, or a failure of your schema check. So what the schema check does is, whatever is the generated JSON in the second step, it compares all the keys with the keys of your sample JSON. If all the keys at the primary object level are same as your sample JSON, then it will give a fuzzy pass. The fuzzy check doesn't check the keys under the arrays, because the child records may be there or may not be there. So example here, under the telecom records, we have again subJSONs with different keys, also the name key, but in the generated JSON those records are empty. Now the reason why these are empty is because of the way we mapped this field. We marked the keys for the mapping for these keys in the membrane as not a field, and therefore it didn't pick up those records. We can check that here under the membrane of the telecom and name keys. Not a field is marked as true. So there wasn't any mapping. Now let us look at another example, another configuration that I have done for Stripe as an external data source, where we achieve a strict pass. So we had a mapping for some of the resources where we could achieve that strict pass. So here, as you can see, this is another org, not the Health Cloud org. I have configured payment method and product for Stripe as an external data source. This is how the membrane looks. If you go to the Healthcheck tab, I have created few of the Healthcheck records where we have a strict pass as the schema check status. When we compare the sample JSON and generated JSON, it will be evident that all the primary keys, then the sub JSON keys which belongs to the lookup, are exactly same as what we took in the sample JSON. So this is how we can use the membrane framework, not just for the FHIR adapter, but in general for any of the integration framework. You just have one single record that defines the schema, the structure of your sample JSON, the mapping, and it also has the ability to generate the data model if the objects and fields are not present. And that one single record can then allow you to generate and consume the JSON. Okay, so from a code perspective, how you can leverage the membrane framework to generate and consume the JSON is very simple. It's just 2 lines of code. When we run the health check behind the scenes, these are the lines of code that gets generated. So for an outbound, that is to generate a JSON from your S object record, you need to query the membrane record, right? And then simply use this method from the class Osmosis and provide your S object record ID. It will then use the mapping which is defined in your membrane and will generate the JSON. Similarly, for inbound, whatever input JSON you get, you use it against the membrane record, and using this method, generate composite graph, um, you can then generate the record as well.